All right, so there are millions and millions of different types of chemical reactions that take place in nature. One of them that you might see in class would be the synthesis reaction, also known as a combination reaction. This is when a chemical or two or more substances react to form a single product. That's your clue that it is a synthesis reaction or a combination reaction, the single product. Okay, it's when one substance combines with another substance to form, again, a single product. That's your hint. Okay, so what kinds of things will undergo this? Well, we have two elements that can come together. We have a sodium metal. It can combine with chlorine gas to form our table salt, sodium chloride. Notice we have, just because there are two of them doesn't mean that this is not a single product. If you have just one product over here, no plus signs, that means it's a synthesis reaction. Another type is when carbon reacts with oxygen gas to form carbon dioxide or carbon monoxide. Now notice that this one, there's only one possible product that can take place because it's ionic. We know that ionic compounds can only have one type of compound together. Or one possible combination. However, these two are nonmetals or are gases. We can have several different types of products. We can have either carbon dioxide or carbon monoxide, depending on what actually is happening here, or possibly both in separate different reactions. Or two compounds can come together. We have calcium oxide can combine with water to produce calcium hydroxide. Notice again a single product. Or a compound and an element can come together. Sulfur dioxide plus oxygen gas yields two sulfur trioxide gas particles. I do also want to note that because these two react with oxygen, these also can be classified as combustion reactions, which you can learn about in another video in more detail. All right, so let's actually look at a video describing what a synthesis reaction looks like. So we have combined sulfur particles and iron particles. Sulfur is the yellow and iron's the black. And we're going to combine them, mix them together to form a mixture. And so we can have them all mixed throughout in this beaker. And then what we're going to do is we are going to put it on the table. And so we're going to spread it out so we have more surface area. So because the greater the surface area you have, the better reaction is going to take place. So we're going to pour it all out on the table. And then we're actually going to require a little bit of energy. Okay, so an energy in this case is going to be in the form of heat. So we're going to bring over a Bunsen burner, which you probably have seen in class. And we're going to light it, and we're going to actually use a glass rod. This is a Bunsen burner. And we're going to actually heat up the glass rod so we can actually have some energy, some thermal energy in this glass rod. Okay, and this actually for some reason takes a really long time in this video. So he's going to heat it up because glass does take quite a while to heat up and actually retain that heat. And then we're going to touch it to the mixture that we have of sulfur and iron. And notice this huge amount of energy that was released, okay? That is showing us that all synthesis reactions are exothermic, meaning it releases energy. It might require a bit of energy, but it releases a lot more than it requires. And now we have a new substance. This is iron sulfide. Okay, and that's our new substance. It has different properties. It completely reacts differently. Notice it's all big block of a new compound. That's an example of a synthesis reaction, one of the reactions that you'll see in class.